Good morning students, how are you all? Good. In the last class, we have discussed about the ionization energy, electron affinity and electronegativity. Okay, let us recall what we have learned in the previous class. So first, ionization energy. What does mean by ionization energy? Ionization energy is the minimum energy is required. The minimum energy is required to remove an electron from a neutral atom and form a cation. Is called the ionization energy. And how the ionization energy varies along the period and across the group. The ionization energy increases across the period and it decreases along the group. So this is about the ionization energy and the electron affinity. So what does mean by affinity? Affinity means attraction. So here electron affinity means attraction of electron towards the atom is called the electron affinity. Here when an electron is added to an atom, it releases some energy. It is called the electron affinity. And here how the electron affinity varies along the period and across the group. The electron affinity here also it increases across the group and decreases along the period. Next, electronegativity. So what does mean by electronegativity? Electronegativity means the tendency of an atom to attract the shared pair of electron towards itself and form a covalent bond. So electronegativity means the tendency of an atom to attract the shared pair of electron towards itself and form a covalent bond. It's called electronegativity. And here also the electronegativity increases across the period and it decreases along the group. So in this class we are going to learn about the metallurgy, steps in metallurgical process, and finally terminology in metallurgy. Okay, before we enter into this topic, we must know about the metals. So, okay, in our day-to-day life situation, metals play a very important role, isn't it? Okay, so copper was the first metal. Copper was the first metal which was used to make utensils, weapons, and many other works. So our human body also contains some metals. Okay, so our human body also contains some metals like sodium, potassium, calcium, iron. Here, where there is any deficiency in this metal, it affects the metabolic activities and it causes some diseases. Okay, and you all know the general properties of metals, isn't it? Okay, let us know the general properties of metals. So first property is metals are solid at room temperature. Metals are solid at room temperature. But here the exception is mercury. Why? Because mercury is a liquid metal. It is not a solid metal. Okay. So the first property is metals are solid at room temperature. And here the exception is mercury. It is not a solid metal. The mercury is a liquid metal. And then metals have high melting point and boiling point. Metals have high melting point and boiling point. And the third property is they are good conductor of heat and electricity. Metals are good conductor of heat and electricity. And then the third property is metals have high density. Metals have high density. Here the exception is sodium and potassium. So the sodium and potassium metals are soft. They have less density. And finally, most of the metals are hard in nature. But here also there is an exception, that is sodium and potassium. So these two metals are soft metals. properties of metals, and the metals have some important properties. Metal has some important properties. They are ductility, malleability, and sonority. Okay, let us discuss what is meant by malleability, ductility, and sonority. So first, what is meant by ductility? So ductility means when a metal is drawn into thin wire. A metal is drawn into thin wire is called a ductility. So then what is meant by malleability? Malleability is nothing but a metal, when a metal is beaten and it can be made into a thin sheets. When a metal is beaten, it can be made into a thin sheets is called a malleability. And finally, sonority. Sonority means when a metal is struck, it produces a sound. When a metal is struck, it produces a sound. This property is called sonority. So these are the three important properties of metals. So the properties are ductility, malleability, and sonority. And finally, the metal have one general property, that is, metals do not dissolve in a liquid solvent. Metals do not dissolve in liquid solvent. So this is about the metals and their general properties. Okay. Now let us move into our topic. So our topic is metallurgy. Topic is metallurgy. So listen children, metallurgy is the science of extracting metals from ores and modify the metals into alloys for various uses based on their physical and chemical properties and their structural arrangement of atom. So metallurgy is the science. Metallurgy is the science of extracting the metal from a ore. Metallurgy is the science of extracting metals from ores. So metallurgy is a metal is extracted from a ore and it is modified into alloys. When a metal is extracted from the ore and then it is modified into alloys for various uses, and it is based on the physical and chemical properties and the structural arrangement of the atom. So this is about the metallurgy. So I repeat, metallurgy is a science. Metallurgy is a science of extracting metals from ores and modify the metals into alloys for various uses based on their physical and chemical properties and their structural arrangement of atom. So this is about the metallurgy. The metallurgy is the science of extracting metals from an ore and then it is modified into alloys for various uses, and mainly it is based on their physical and chemical properties and then structural arrangement of atoms. So the next topic is steps involved in metallurgical process. Here there are three main steps which are involved in the metallurgical process. So the first step is concentration or separation of the ore. The first step is concentration or separation of the ore, and the second step is production of the metal. Second step is production of the metal, and the third last step is refining of the metal. The last step is refining of the metals. So let us discuss the steps one by one. So the first step is concentration or separation of the ore. It is the process of removing the impurities. It is the process of removing the impurities which is present on the ore. So concentration or separation of the ore is nothing but it is the process of removing the impurities impurities which are present in the ore. It is called the concentration or separation of the ore. It is the first step. And the second step is production of the metal. Second step is production of the metals. Here metal is produced. Here the ore is converted into metal. So the first, in this first step, removing the impurities is the first step from ore. And the second step is the ore is converted into metal. That is called the second step. And the third one is refining of the metal. Third one is refining of the metals. So refining of the metal means purifying the metals. So it is the purifying the metal. So these are the three steps which are involved in the metallurgical process. In the first step, the ore, the impurities which are present in the ores are removed. So first step is removing the impurities which are present on the ore. So that step is called as concentration or separation of the ore. The second step is production of the ore. In this, the purified ore is converted into the metal. Purified ore is converted into metal. And the last final stage is refining of the metal. Refining of the metal means purifying the metals. So these are the three steps which are involved in the metallurgical process. And the next topic is terminology in metallurgy. So last topic is terminology in metallurgy. So here we are going to discuss about some terms in metals. So the first one is minerals, ores, mining, gangue or matrix, flux, slag and smelting. So let us discuss the terms one by one. So the first one is minerals. What are minerals? Here, minerals are naturally occurring materials. Minerals are naturally occurring materials which contains metals. So minerals are naturally occurring materials which contains metals. So as you know, metals are highly reactive. Metals are highly reactive and they always exist in the combined state. Because metals are always exist in the combined state. So this is about the minerals. So mineral is the naturally occurring material which contains metals. So the metals are highly reactive and they always exist in the combined state. And then ores. So ores are also a minerals. Ores are also a minerals. Here minerals contains less percentage of metals. Minerals contains less percentage of metals, whereas ores contains large percentage of metals. So it is easy to extract the metal from the ore, but it is not easy to extract the metal from the mineral as it contains less percentage of metals. Okay, let me give you an example. Here clay and bauxite. So the formula for the clay is Al2O3 dot 2SiO2 dot 2H2O, and the formula for bauxite is Al2O3 dot 2H2O. Here these two are the minerals of aluminium. These clay and bauxite are the minerals of aluminium, but the bauxite is the ore of aluminium. Bauxite is the ore of aluminium and clay is its mineral. Listen children, clay and bauxite are minerals of aluminium. Okay, but bauxite is the ore of aluminium and clay is its mineral. Okay, because this bauxite contains large percentage of aluminium, whereas the clay contains Aluminium. So aluminium can be extracted only from the ore. Aluminium can be extracted only from the ore because it contains large percentage of aluminium, and clay contains less percentage of aluminium. So it is not possible to extract an aluminium from the clay. Bauxite is the ore of aluminium. Bauxite is the ore of aluminium because the aluminium is extracted from bauxite only, and it contains large percentage of aluminium, and clay contains less percentage of aluminium. So it is not easy to extract an aluminium from the clay. So bauxite is said to be an ore of aluminium, and clay is its mineral. Clear, children? So ore is also a mineral. This mineral contains less percentage of metals, whereas ores contain large percentage of metals. So clay, and let us take an example of clay and bauxite. These two are the ores of minerals of aluminium, but aluminium can be extracted only from the bauxite. So bauxite is said to be the ore of aluminium, and clay is said to be its mineral because clay contains less percentage of aluminium. So it is difficult. So it is not possible to extract the aluminium. So this is about the ores. And then mining. The third term is mining. So mining is the process of extracting ore from the earth crust. Mining is the process of extracting the ore from the earth crust. So this is about the mining. And the fourth one is gangue or matrix. Fourth one is gangue or matrix. So it is nothing but a rocky impurities. It is a rocky impurities like sand, soil. So which are present in the ore or called the gangue or matrix. So gangue or matrix is nothing but the rocky impurities like sand or soil. So the rocky impurities which is present on the ore are called the gangue or matrix. So the next term is flux. So the flux is nothing but a chemical substance. Flux is a chemical substance. When we add a chemical substance, that is flux, when we add a chemical substance into a ore, it reduces the fusion temperature and removes the impurities from the ore. So a flux is a chemical substance. When we add this chemical substance into a ore, it reduces the fusion temperature and removes the impurities from the ore. And then slag. A slag is when flux and gangue reacts. When flux and gangue reacts, it produces a fusible products. When flux, that is a chemical substance, and the rocky impurities reacts together, it produces a fusible products, that is slag. Okay. The next last one is smelting. So smelting is reducing the roasted metallic oxide to the metals in the molten state. So smelting means reducing the roasted metallic oxide, reducing the roasted metallic oxide to the metals in the molten state. So this is about the smelting. So these are the important terms which are involved in the metallurgy. So I repeat, the first term is mineral. So the mineral is a naturally occurring material. It contains metals, and the metals are highly reactive and it always exists in the combined state. And then ores. So ores is also a minerals, whereas minerals contain less percentage of metals, whereas ores contains large percentage of metal. So it is easy to extract metal from a ore, and it is not easy to extract extract the metal from the minerals as it contains less percentage of metals. So let us take an example of clay and bauxite. These two are the ores of minerals of aluminium, but aluminium can be extracted only from the ore, and because it contains a large percentage of aluminium. So the bauxite is said to be the ore of aluminium, whereas clay is its minerals, because clay is also containing aluminium, but it has very less percentage of aluminium, so it is not easy to extract the aluminium from the clay. So bauxite is said to be a ore of aluminium, and clay is said to be its minerals. And then mining. Mining is the process of extracting the ores from the earth crust. And then gangue or matrix, it is nothing but a rocky impurities. So the rocky impurities like sand and soil, so the rocky impurities which are present in the ores are called a gangue. And then flux. So flux is a chemical substance. So when we add a flux, that is a chemical substance, into a ore, it reduces the fusion temperature and removes the impurities. And then slag. So slag is when a flux, that is a chemical substance and rocky impurities reacts together, it forms a fusible product, that is slag. And then finally smelting. So smelting is the reducing the roasted metallic oxide to the metals in the molten state. So these are the important terms which are involved in the metallurgy. So the next topic is types of separation or concentration of an ore. The next topic is types of separation of an ore. In this, there are four methods we can separate the ore. So the first method is hydraulic method, the second method is magnetic separation method, and the third one is flotation, and the fourth one is chemical method or leaching. So these are the four methods by which the ores can be separated. Okay, let us discuss the method one by one.
So hydro means water. So the oxide ore is purified by this process. So the crushed ore is placed on the slope of a vibrating table. When a jet stream of water passed through this ore, the lighter impurities are washed away by water, while the heavier particles settle down in the groove. This is about hydraulic method. And the next one is magnetic separation method. This method is based on the difference in the magnetic properties of the ore and the gangue particles. So the crushed ore is placed on a conveyor belt which rotates around two metal wheels, one of which is magnetic. The magnetic particles are attracted to the magnetic wheel and fall separately apart from the non-magnetic particles. This is about the magnetic separation method. And then flotation process. This method is based on the difference in smelting properties of ores and the gangue particles. So this method is based on the difference in smelting property of ores and the gangue particles. So in this method, the crushed ore is taken in a large tank containing oil and water and agitated with the current of compressed air. Then the ore is wetted by the oil and gets separated from the gangue in the form of froth. Since the ore is lighter, it comes on the surface with the froth and the impurities are left. Impurities are left behind the ores. This is about the froth flotation process, and this process is based on the difference in smelting properties of ores and the gangue particles. The last one is chemical method. So this chemical method, it is also known as leaching method. So it is based on the solubility of ore on the suitable reagent. It is based on the solubility of ore on the suitable reagent. So in this method, the ore is treated with a suitable reagent, that the ore is soluble in it, but the impurities are not. So the impurities are removed by the filtration process. So the solution of the ore is treated with a suitable reagent which precipitates the ore. So I repeat, the chemical method is treated with a suitable reagent such that the ore is soluble in it, but the impurities are not. Then the impurities are removed by the filtration process. Then the solution of ore is treated with a suitable reagent which precipitates the ore. So this is about the chemical method or leaching.
So the next topic is occurrence of ores in Tamil Nadu. Next topic is occurrence of ores in Tamil Nadu. So these are the ores which are occur in Tamil Nadu. So the ores are limestone, gypsum, titanium minerals, chromite, magnetic and tungsten. So the limestone is occur in Coimbatore, Kadalur and Dindigul, and the gypsum is occur in Trichy and Coimbatore districts, and titanium minerals. This mineral is occur in Kanyakumari, Tirunelveli and Tuticorin, and then chromite. So this chromite is occur in Coimbatore and Salem districts, and then magnetic. So this magnetic is occur in Tamil Nadu or Dharmapuri, Erode, Salem and Tirunelveli, and finally tungsten. So this tungsten is available in Madurai and Dindigul. So these are the ores which are present in the Tamil Nadu. Okay. We are discussing the lesson periodic classification of elements. So in the last class we have discussed about the metallurgy and then terminology in metallurgy and finally types of separation of an ore. Okay. So first, now tell me what is meant by metallurgy. Metallurgy is a science of extracting the metal from a ore. So this is the metallurgy. And then terminology in metallurgy. So what are the terms which are involved in the metallurgy? So here there are some important terms which are involved, which are related to the metallurgy. So they are metals, ores, gangue, flux, slag, refining and mining. So these are the terms, important terms which are related to the term metallurgy. aluminum is treated with the diluted water, and we have aluminum hydroxide and sodium hydroxide. So here this aluminum hydroxide is in the form of precipitate. So before entering into the third step, we must filter the aluminum hydroxide and then ignite it under the pressure of 1000 degree Celsius, and finally we get the alumina. So the formula for alumina is Al2O3. Okay, so this is the base process. So the conversion of bauxite into alumina. So we are taking the alumina, and then finally we are taking bauxite, and finally we get alumina. So this is the base process which involves the 3 steps. Okay.
So the second one is Hall's process. So the Hall's process, alumina is converted into aluminium by electrolytic reduction method. The Hall's process is conversion of alumina into aluminium by the electrolytic reduction method. So this is the second step which is involved in the extractive metallurgy of aluminium. So here cathode is iron tank linked with the graphite, and the anode is a bunch of graphite rods. Anode is a bunch of graphite rods suspended in molten electrolyte. So what is meant by electrolyte? So here electrolyte is a pure alumina, and it is the combination of pure alumina, molten cryolite and fluorspar. So here fluorspar is the fluorspar which lowers the fusion temperature of the electrolyte. Fluorspar lowers the fusion temperature of electrolyte. So electrolyte is the combination of pure alumina and cryolite and fluorspar, and here it is treated at the temperature of 900 to 950 degree Celsius, and 5 to 6 voltage is applied in the Hall's process. So the overall reaction of Hall's process is Al2O3, which gives 4Al plus 3O2. So this is the overall reaction in the Hall's process. So here the aluminium is deposited. So the final product of aluminium is deposited at the cathode, and the oxygen is liberated. In the overall reaction, the oxygen is liberated. So this oxygen is liberated at the anode. Okay, so there is a cathode and anode. So the final product of aluminium is deposited at the cathode, and the oxygen gas which is liberated is at the anode. Okay, so oxygen combines with the graphite to form carbon dioxide. Okay, oxygen combines with the graphite to form carbon dioxide, because anode is nothing but a bunch of graphite rods. Anode is a bunch of graphite rods. So here the final product of aluminium is deposited at the cathode, and the oxygen gas is liberated at the anode. So the oxygen combines with the graphite which is present at the anode and form a carbon dioxide. So this is the Hall's process. So I repeat, in a Hall's process, alumina is converted into aluminium by electrolytic reduction method. So here cathode, anode, electrolyte, and the cathode is a iron tank which is linked with the graphite, and anode is a bunch of graphite, and electrolyte is the combination of pure alumina, cryolite and fluorspar. So the nature of the fluorspar is lowers the fusion temperature of electrolyte, and here 900 to 950 degrees Celsius is applied, and then 5 to 6 voltage is used in the Hall's process. So finally we get aluminium and liberation of oxygen. So the aluminium is deposited at the cathode and oxygen is liberated at the anode. So in anode, graphite is present. So oxygen combines with the graphite to form a carbon dioxide. So this is the Hall's process.
So the next topic is chemical properties of aluminum. So far we have discussed about the discussed about the steps which are involved in the extractive metallurgy of aluminum. In this, two steps are involved. That is one is base process and another one is Hart's process. Now we are going to learn the chemical properties of the aluminum. So the first chemical property is reaction with air. First, aluminum is not sulfate and some water and sulfur dioxide. So when aluminum is treated with concentrated sulfuric acid, we get sulfur dioxide, and when treated with the diluted sulfuric acid, we get aluminum sulfate, and when aluminum is treated with both the dilute and the concentrated hydrochloric acid, we always get aluminum chloride and some liberation of hydrogen gas. So this is about the reaction of aluminum with acids. And then finally, as reducing agent. So aluminum is a highly reducing agent. Aluminum is a highly reducing agent. So here iron oxide. Iron oxide is treated with aluminum. We get iron. Iron plus some heat. So when aluminum is treated with the iron oxide, we get metal. So this property is known as the this is the reducing agent. Okay. So these are the chemical properties of the aluminum. So the first property is reaction with air, and the second one is reaction with water, and the third one is reaction with alkali, and the fourth one is reaction with acids, and finally aluminum as a reducing agent. Okay, so these are the chemical properties of the aluminum. So the next topic is physical properties of aluminum. So the first property is aluminum is silvery white metal. So we all know aluminum is silver in color. So it is a silvery white metal, and then it has low density. Aluminum has low density. So because of this property, aluminum is used in making aeroplanes. Okay, so aluminum has low density, and then it is malleable and ductile. So as I said before, what is meant by malleable and what is constitutive properties of the aluminum, so as I said before. And then A combines with O2. So here aluminum reacts with O2 to form B. So B is aluminum oxide. The